Hello and good morning. Welcome to Utkarsh Minds, Foundation for Data Science. Today we will see two variable hypothesis testing. So two variables means that there are two columns in the table. For example, the first will be gender and the second is maybe school. And in the question, gender can be male or female, and school has the option Netherlands or other. So these are both binary variables as there are only two options. In this analysis, that is why the reason the title is binary versus binary. Here we are talking about unpaired variables. We will see what is the meaning of unpaired in next video. So here the question that we want to solve using data science is, does the gender of the person influence whether or the location of the school? So does being male means that the student will go to Netherlands, and does being female mean that the student will go to other countries? Or is there no such relationship or influence between gender and school? Here any analysis will begin with descriptive analysis. In descriptive analysis, we will first make a table of the two variables known as the cross table. Further, we'll be visualizing the data in the form of a clustered bar chart, and finally we will be using the hypothesis test for understanding the influence. This hypothesis test will be the Fisher exact test, followed by the effect size known as odds ratio. Finally, this first, second, third and four parts will be together put up in this final report. So our first step is to create a cross table or a contingency table. Remember that data has two parts. One, the gender, I will call it G, and other is the school, I will call it S. We are interested in finding out the gender versus location of secondary school. So there is the first option Netherlands, the second option other for the school location, and how many females and how many males are there at each location. So 73% of the female prefer Netherlands, 52% of the males prefer Netherlands, whereas 27% of the females prefer others, and 48% of the females they prefer other, of the male prefer other. Looking at these percentages, can we say that there is some influence of gender on the location of secondary school? The data for male is pretty balanced. Here the data for females is looking imbalanced, as 73% prefer Netherlands. However, only the hypothesis test will tell us whether or not the data, what is the story behind this data. The visualization is a type of multiple bar chart, or it is a clustered bar chart. You can see that there is legend male and female. Female is blue, male is orange, and on the x-axis there is Netherlands and there is other. And here we have the percentage of gender. So we can say that 73% and 20. So this is the female and this is the male. Finally, the test checks whether there is an association or influence of gender on the location of secondary school. Here the null hypothesis will be no influence or no association. No association. And alternate hypothesis will be that there is an association. And we have to prove which is correct. So if the p value is less than 0.05, then we will say that null hypothesis is rejected and we will go for the alternate hypothesis. If there is an association, then we need to find out how big or small is that association, and that we will find out with the help of effect size, which is named as odds ratio. There is an interpretation of odds ratio depending on its number or value: negligible, small, medium and large. So we will see in the next video how we can get all these 4 things in Python and how we can apply the Fisher exact test on our data. So the code will be applied on some sample data set, but you can always change the data set and use any other data set that you are interested in. Thank you for watching this video, and looking forward to see you in the next video on Python exercise.